Alright, I know that this pre-lecture video got up late, but better late than never. And in both this pre-lecture video and the next one, I wanted to show you how you can do ray diagrams to figure out where an image is going to be placed. It's sort of a tedious procedure because in order to really get the proper results, you need to really be careful and measure things and do things to scale. But I also think that it's sort of a way for you to get a rough idea about what an image is going to look like with respect to, will it be enlarged, will it be inverted, is it going to be real or virtual. I think that you can get these types of results fairly easily if you know what the main light rays are that you can draw. So for the first slides, what I'll do is I will sort of make a rough sketch showing you the different rays and how they work out, and then we'll see them done with the professional pictures that we can take a look at that might be a little bit easier to follow. So here is our converging mirror, and I drew this central axis through the center, and 2 points that I need to show on here are the center of curvature, which is point C, and then of course then the focal point, which will be F. And so what we're going to do is we're going to draw these 4 rays and just be nice, because maybe we won't have the lines intersect all together, but at least we get an idea of how we draw them. So here's my object. And what I'm going to do is I'm going to draw all my different rays, and I'm going to try to make them different colors so we can keep track of them. So the first one, number 1, is my green one. If we take a light ray from the tip of the object and it goes parallel to the central axis, so it goes into the mirror like this, keep in mind that's sort of the definition of what the focal point is, and so it's going to reflect and go through the focal point after it goes out. And then the nice thing we can do is for the second one, we can draw sort of the opposite thing, and this is going to be the blue one. So that one, if the light ray goes through the focal point on the way to the mirror, when it comes back out, it's going to be parallel to the axis. And so in a sense, this is sort of where we could already say where our image is going to be. And because these 2 light rays intersect at the same at one location right here. But to be a little bit more precise, we could try some other light rays and see how that goes. The third one, if it goes through the center of curvature, it will hit the mirror at a right angle, and so then it just will bounce right back on itself. And so here you can see I'm having a little bit of trouble, but this is what the light ray would look like in general. And I was more careful about making it intersect than anything, but I think you get the idea. And finally, for our last one, this light ray is going to, if it hits the vertex, and this is the vertex, so if it comes in, hits the vertex, it's going to reflect back at the same angle, and then because I kind of made them, all my light rays do intersect at a certain spot, and that's where my image is going to be. And so here is my image. And we see that in this picture, my image is inverted, it is reduced, and it is, real. It's real. So we can take a look at the next slide to see these pictures drawn. And I think I did a fairly good job. You know, here, number 1 is the light ray that goes in parallel and reflects through the focal point. Number 2 is backwards of that. It goes through the focal point on the way and then reflects back parallel. Number 3 was the one that went through the center of curvature, and so it reflects back on itself. And finally, number 4 is the one that hits at the vertex and reflects back. And here we see our image. Right here is the image, and again, we can see that my results are consistent with this better picture, where it's inverted, reduced, and real. So in the next picture, what we're going to look at is the ray diagrams for a diverging mirror, which are a little bit trickier to draw because they just are. So a diverging mirror looks more like this. It's convex, and the center of curvature is going to be over here. And likewise, the focal point is going to be over here. Remember those, that means those values are negative. And so I'm going to draw my image, my object right here. Because it seems like when I have to draw the lines really long, it's hard for me to draw them straight. So I'm going to try to make it easy for myself there. So, if I draw my first picture, my first ray, this is the one. Now see, what happens is when the light ray comes in parallel to the axis, it can't go through the focal point because of the fact that the focal point is behind the mirror. But what happens is the reflected light ray appears to have come from the focal point. And so that's what that light ray looks like. And then for the second one, the light ray that looks like, as it's coming in, looks like it's going to be going through the focal point if it would continue on. And so when it reflects back parallel to the axis. And of course you see that these two light rays don't intersect. Remember, for the converging mirror, they intersected right away, but it's a diverging mirror. It isn't going to produce a real image. And so here, the third one, the one that appears to be going through the center of curvature, this one's going to be a little harder to draw, is just going to reflect back on itself. And finally, so that one was the red one. The last one, the one that goes and hits on the axis, is just going to reflect symmetrically. And that will be this one. And so, except for my focal point one, they all seem to intersect at this location, which that's okay because I'm just doing a rough sketch. And so this is where my image is going to be. And of course my image is virtual because it did not actually come from the intersection of light rays, but where they appeared to have originated. It's reduced, it's upright, and that's for my diverging mirror, the picture from where the light rays are drawn for us and more accurate. And you see the results are pretty similar. You can also see, because it was drawn a little bit better, that how my light rays are reflecting and or how they're extending and intersecting. And so those are doing ray diagrams for mirrors. Again, I find it's kind of nice to sort of see how you can predict where an image is going to be, and also you can predict if it's upright, inverted, etc.